Good morning, everyone. The purpose of this video here is to go over power and energy dissipated by a resistor. So we'll go ahead and get started here. First of all, this here, and I don't know how well you can see that. There we go. This is a resistor. Now, let me turn it around. Maybe that's better for you. There are color codes, or colors on here, and what you do is you look at a chart, and each color corresponds to a number on the chart, and you kind of put the numbers together. Then this third color is what they call a multiplier, and like the multiplier is 1 or 10, 100, 1,000, so on and so forth. And you just so you put the first two numbers together. So let's say the first number is 5, the second number is 3, so it's 53, and then let's say the color is red, so the multiplier is 100. So the resistance value of this resistor is 5,300 ohms. Anyway, this is what a resistor looks like, and it's a device that controls the flow of current to other components of the circuit. You have resistors, you use them every day if you use things like electric heaters, ovens, toasters, and all electronics devices. So of course that includes the almighty cell phone. Now, what we have, got a lot going on here, but it's not too bad really, I promise. What we have here, we have a basic power equation that you'll use in situations where the problem does not address the idea of a resistor. If it mentions nothing about a resistor, you're using this equation here, P equals I times V. So the P stands for power, which I forgot to label. Current is I, and voltage is V. So as an example here, let's say we're talking about something, some kind of a device, electric heater, let's say, requires 13 amps of current to make it run, well. And then you plug it into your standard electrical outlet, 120 volts. So you're trying to figure out the amount of power there, and so you just multiply current times voltage, and you get 1,560. The units of power are called watts, like a 40-watt light bulb, W-A-T-T. So just indicate that, capital W, and you're good to go. Now, so there's this equation. Then, when there's problems that are talking about the power that's dissipated by a resistor, because that's what a resistor does. There we go. All right. The power is dissipated by the resistor. Well, that's great. The question is how much power, and that's the beauty of physics. We talked about different things that you already know about. Now we quantify those measurements. We beat acceleration pretty much into the ground earlier this school year. So you have two equations here. First one is P equals I squared times R. And the second equation is P equals V squared divided by R. Listen carefully. You use one or the other equation. The question is, how do you know which equation to use? That answer is, it depends on what's given to you in the problem. In every problem, you're going to be given a resistance value. The 9 ohms, 8 ohms, whatever. So then the other bit of information is you'll either know the current or you'll know the voltage. One or the other. You will not use both of these equations in the same problem. You will not do it. It's either this equation or this one. I hope that's clear. Either this equation or this equation. In this example here, we happen to know that, you'll see this example, the resistance is 9 ohms, 120 volts. Aha, voltage. We know the voltage, we don't know the current. So we're going to use this equation here, P equals V squared over R. Notice we square the voltage. All right, so 120 volts, 120 squared. We're dividing it by the resistance of 9. 120 squared is 14,400. Again, divide that by 9, you get 1,600. And so these problems basically consists of two parts. The first part is what's the power that's dissipated by the resistor, and that's what this number represents here. All right, so it's the power dissipated by the resistor. This is a lot neater looking for you on the worksheet compared to my not so good penmanship up here on the old dry erase board. Anyhow, so that's part one. There's always two answers here. The first answer is you're calculating the power dissipated by the resistor. The second question that you're answering here is what's the total amount of thermal energy that flows in X number of seconds. When I say X number of seconds, the number varies, but you always know what the seconds are. So you take the power that you just calculated, 1600 is what this says, 1600. We're going to put it into this equation. It says E equals P times lowercase t. All right? E equals P times lowercase t. All right? Energy, thermal energy, in all honesty, is power times time. Time's measured in seconds. The time is already in seconds. You don't have to convert. All you have to do is remember to answer the second part of the problem. All right, so the first part of the problem, again, answers the question what power, the amount of power that's dissipated by the resistor. The second question asks you what's the amount of thermal energy that flows in this case, 30 seconds. So what you do here, power times time, all right, so 1600 times 30 is 48,000. 48,000 watts. Now, in some cases, you will be asked to take it a step further, where I'm going to ask that you convert this second answer here, this amount of energy, and only the amount of energy, you'll have to convert, you're going to be asked to convert that to kilowatts. Okay? All you do is you're going to take 48,000, let me rewrite this so it's a little bit better to see. You're going to take your answer from up here, 48,000 watts, and you're going to divide it by 1,000. Now, the way I set this up, whoops, too many zeros. There we go. All right, the way I set this up is I set up here what we call dimensional analysis. All that means is you're showing how units cancel out. Do you have to show dimensional analysis like I did there? No, you do not. What you need to do, just make sure show me the work that 48,000 divided by 1,000 is 48 kilowatts. Okay? You can just do, 48,000 divided by 1,000 is 48 kilowatts, and that's fine. Don't just write the answer because you're going to get docked a point because you didn't show work. So remember, always show your work. So with these problems, you have two answers. All right. Again, the first answer is calculating the power dissipated by the resistor. And the second answer is calculating the thermal energy that flows in whatever time frame I give you, 60 seconds, 90 seconds, whatever the number is. So the power times time, 48,000, and then again, convert that to kilowatts. So in all honesty, for these problems, I'm looking for three answers. All right, looking for the power, looking for the energy in watts, and then looking for the energy again in kilowatts. All right, so there's your three answers. Now, remember, you're going to use one or the other equation here, all right, when it's talking about the power that's dissipated by a resistor. If it says nothing about a resistor, kind of like we did here with this basic power equation, then don't use this. All right? Because this one won't work anyway. All right? And really neither of them will work because you're not going to know the resistance. You're not going to know the value of the resistor. So you can't use either of these equations for something when you're using this one. All right? They're not interchangeable at all. But again, use this one when it says nothing about a resistor. Use either one of these equations when it says, how much power is dissipated by the resistor. Then it's going to be your job to figure out, okay, which equation do I use? Does it say something about current? Why, yes, it does. Boom, here's the equation I use. Next problem might say, you know, resistance, blah, 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 blah. It might say something about voltage. Aha, what do I use? This equation, right? Because it has voltage in it. And you're just going to solve for power. And again, in either case, if you're using this equation or this equation, here's the second part. So make sure you use that as well. All right, now I know that I've thrown some information at you, just checking the time there, make sure I don't go over, you know, the time limit here. But throwing a little bit of information at you, you know, if you need to back up and watch parts of this video or do what you have to do, that's fine. But the worksheet rather, power and energy dissipated by resistor is posted. It was posted several hours ago on Google Classroom, so now you have the video to help you with that. So, you know, buckle down, take care of business, and, you know, if you have any questions, let me know. I'm, of course, more than happy to give you a hand.